All right, I think it's about 3:15, so I'll just get started. First of all, I appreciate everybody showing up in the afternoon on a very busy day. Hope you all got some water and food so you stay strong and stay with me here. What I'm going to be presenting is an introduction to Amazon EC2. And by the way, my name is Sebastian. I'm with the EC2 or Compute Business Development team. So the introduction to EC2 is always a bit tricky. As you know, it's one of our core building blocks. And when we have these sessions, we usually have about 50% or so of the audience completely new to AWS, really needing to sort of get a grasp of how does EC2 work, what are all the acronyms, how do things relate to one another. And as you have spent, most of you have spent a large part of the day here, you might have heard a lot of the acronyms already and understand what some of them are. But what my goal here is to kind of put things into perspective as it all relates back to EC2. And then the tricky part comes from the fact that maybe 20, 30% of the audience has had a chance to fire up or sign up for an AWS account already, fire up a couple of EC2 instances, kick the tires, and has had the opportunity to start thinking about what do I want to build on EC2 in the future. And those people usually need a couple of specific questions answered. And so I'll have a couple of tips and tricks here about certain things that might be helpful as you set up an environment, as you start thinking about what is EC2 and how do I want to use it. And then there's usually around 10 to 20% of people in here that have been here last year that know very well what they do, and they just kind of wait for me to show them maybe a few things that have changed that they might have not noticed in the breadth of new features and services that we release all the time, like we did this morning with Elastic File Share and machine learning and a couple of the other services. So this will be all about EC2. It'll truly be an introduction and a primer, and then I'll see if I can give some of the other people that are a little bit more advanced something to think about and go back home with and introduce at home to their own AWS environment as well. So the very basic question, what is EC2? EC2 stands for Amazon's Elastic Compute Cloud. So those are virtual servers in the cloud. A couple of terms that you might have heard already today, or probably heard or are aware of, are we have AWS regions. So regions are where we have a presence globally with our data centers where there are servers that you can provision. Within regions, we have availability zones. Availability zones have a different blast radius, so they have close proximity and close latency with one another, which is why there are both or multiple AZs within a region. But they're separate from one another for you to then build highly available architectures on top of. And I'll talk a lot about that in a little bit more in detail after that. But we have regions. We have availability zones within those regions. Availability zones are comprised of either one or more data centers. And within those data centers, we have hardware. That hardware is virtualized, is managed by a hypervisor. And that hypervisor manages the guests on that hardware. And those guests are virtual machines, or what we call EC2 instances. So just to kind of put it into perspective all around EC2. And I should have done that a little bit earlier, but I think you got the point. So the majority of what I want to talk about today is the virtual machines, which is what many of you think is EC2, and it truly is. But EC2 obviously relates to many, many different parts of our business. Networking plays a role when it comes to performance and security, the user experience. We have different purchasing options for our virtual servers, for our EC2 instances, so I'll stick to our nomenclature now. And I'll touch upon all these different areas, but that said, within the 1 hour we have and the different topics that are relevant to all of you, I might be able to just give you an overview of some of those areas, and then there are different talks and there are different recordings of talks online that you can use to dive a little bit deeper on these topics. So a brief look back, going back to the core of this talk, which is the virtual machines. EC2 is 8 years young. That said, it's one of our oldest services. But 8 years young, back in the day, we started with just one single instance family in size, which was an M1 small. Had one vCPU, 1.7 gigabytes of RAM, 160 gigabytes of storage. We had them available in Linux and with the on-demand pricing model. So a couple of things that I have here on the slide are the words only and single. And this is clearly to kind of make the distinction of what all happened in the meantime. But the truth is that was a pretty magnificent shift back then, right? That was a paradigm shift. All of a sudden, you were able to provision capacity on demand in the cloud, as opposed to having long lead times and capital expenditures and all this planning that goes into putting a server on the ground and actually making it work for you. So the only and single, I kind of don't like those words here, but kind of just to show you what happened since then. So what did happen since then? People basically started using it because it was awesome. It was great. It was that paradigm shift that we thought it might be. But they also had a lot of feedback. And the feedback was, this stuff is great, and I want to use it, but I have workloads that require more, right? This M1 small, yeah, I can scale it horizontally, and I can add more of those machines, but I need bulkier machines, I need machines with more memory, and on and on and on. So what happened since then is that we created a lot of instance choice around CPU, memory, and storage. So if you talk about an instance today, an instance is the combination of a certain amount of resources around networking, storage, memory, and CPU. And so we have categorization there that allows for you to select the right instances for the type of workload you have, for the right, for maybe the bottleneck that's being created within your workload that is very hungry for CPU or that's very hungry for memory. We have different deployment options. We have different operating systems now. We have applications that you can, one-click launch. We have Amazon Elastic Block Store. We have VPC, Elastic IP addresses, auto-scaling, load balancing. I'll go over all of these just a little bit, just to kind of outline what they actually are and what they mean to EC2 and how you can use them. That said, there are a lot of these that have their own sessions and that sort of require their own time if you want to really dive deep. One that I'm not going to go over at all is the last one and one of the last services that we introduced into general availability just this morning, which is Amazon ECS, our EC2 container service for managing fleets of containers on top of your virtual instances fleet or your EC2 instances fleet. There's a talk right after this one by the lead product manager on ECS, Chris Barkley, that can tell you a lot more about how ECS works, how it's beneficial, how it supports Docker. So anybody that is into containerization, wants to utilize Docker, I would highly recommend that you join that talk after this one. I don't know exactly where it is, but I know it's right after. So globally, obviously, there's also a lot that happened. Where we started with just one region back in the day, we now have 11 regions. We have 28 availability zones within those regions. We have edge locations for content delivery, and for you to just be closer to the different customers you might be serving out there for latency requirements. And obviously, our customer base changed, and you'll see how that has a networking effect on some of the things we have created since then that you can take advantage of. So Andy said this morning in his keynote talk that the network effect is something not to be underestimated in regards to a lot of different topics, such as, for example, security. And then with that customer base, we now have hit over 1 million active customers across 190 countries. And actually, seeing Andy's talk this morning, I think some of my numbers might already be out of date. But I'm sure he has the latest. 900 plus government agencies, 3,400 plus educational institutions, 11,200 plus nonprofits around the world. So obviously a lot different than what we could list about 8 years ago. This is something that kind of puts that growth into perspective. It's something that happens today and has been happening for a while, which is the fact that every day Amazon Web Services adds enough new server capacity to support all of Amazon's global infrastructure when it was a $7 billion enterprise. So that might still be a number that's so large that it's still hard to kind of grasp. But if you just think about that, for the people in the audience that are already working for an enterprise that might be of significant size, or if you're a startup and you think about the fact that Amazon.com is an internet company and probably requires quite a bit of hardware that back in the day was significant enough to power a $7 billion enterprise worldwide, that's how much capacity lands on the ground for Amazon Web Services every single day. So with all that choice that we introduced and with the different workloads that we want to support and with the feedback we got from our customers, we have started dividing up instances into what we call families. So that would be on the left-hand side here, what you see, the general purpose, computer optimized, and so on. And it's relatively self-explanatory, I would hope, but general purpose instances are basically instances that have a relatively, what we would call even distribution or ratio between the resources that make up an instance. So things like CPU, memory, networking, and local storage. So we have a combination in the general purpose instance family that can support a lot of different types of workloads, and that is also good for getting started if you don't know your workload well yet. That's something that we would recommend, is that you start with the general purpose instances and then just see, do I have a certain bottleneck, or is my workload hungry in one area versus another? We have compute optimized instances. Obviously, a lot of vCPU, a lot of power to power your workloads. Then we have memory-optimized instances, and then we have high storage or dense storage instances. There's actually two subcategories. For some of you that have been at the previous talk, which was the introduction into databases, you noticed that Brian was talking about using some of these instances underlying some of your database, managed database services that we offer. So for memory-optimized instances, probably for something like the caching databases, and then dense storage, the D2, for example, for data warehousing. But the difference here, and why I divided it up, is that the dense storage ones come with a lot of storage, and that's magnetic storage usually, and just a lot of local storage that you can use for something like data warehousing, whereas the I/O optimized also come with a lot of storage, but it's SSD-based, and it can support a lot of IOPS. Then we have GPUs. This is something I'm not going to go into detail over today. It probably is very important to a small set or a specific set within the audience here today. I just want to be sure that you're aware that we have GPUs. They're very interesting to customers that do something like game streaming or 3D rendering, maybe machine learning or deep learning, where you can train your models with GPUs and really accelerate your time to results and your time to improving your model. And then we have micro instances, which is a term that I would rather leave off because it's kind of evolved over time. From the T1 to the T2 was a big step in improvement. So the T2 is now really an extension of our general purpose instance family. The reason I still have that category down there is because there's something else unique about it, which is the fact that those instances in the micro family are available in the free tier. So when you sign up for an AWS account initially, you get a certain amount of hours for free that you can use these instances. So that said, we have our families that kind of like help you divide up the world and think of your workload versus the EC2 instances from the get-go. And then we have generations. And generations are improvements we have made within a family over time. And those improvements come back to a couple of performance factors that I'll go over. Basically, what I want to highlight here is the orange instances, which are the latest instances. You can always think of them as either the highest performing or the best price per performance, or usually both. So anybody that starts new, I would encourage you to look at those. Anybody that's been using AWS for a while, I would encourage you to benchmark and test some of the latest instances to see what kind of improvements you get for your workload. Then we have the third step within the hierarchy. So we have families that let you divide up the world in a broad sense. Then we have generations, and then we have sizes within those. So as I mentioned earlier, you can obviously horizontally scale. You can just add new servers, or you can actually get bigger servers as well. So as your workload is larger and you might benefit from a larger instance, you can actually have different sizes of, for example, an M3 instance. All that is best summed up right here. So this is actually an API name for a specific instance type. So an instance type or API name shows you a summary of all the information we just talked about for the last couple of minutes, which is the C in the API name stands for the family that the instance belongs to, which is in this case the compute intensive. Then we have the number 4, which means it's the fourth and currently latest generation of that family. And then we have the large, which is the size. So the sizes, as you might have already seen on our website, usually go from something like micro on the smallest instances all the way up to 8 extra large. And depending on family, it ranges from maybe just medium to 8 extra large, or micro to medium, and so on and so forth. But as you go up in size, you double your resources that you have within that instance. So you can basically think of it, the vertical and horizontal scaling as just two options or as an option that has two choices for you that result somewhat in the same resources that are available to you. So if you run 2 mediums or 1 large, you get the same amount of resources around CPU and memory and storage, and you also have that larger instance cost twice as much. So it's your choice which way you want to scale. So here's the performance factors that go into the fact that we have now different generations within those families. The first one is CPU. As many of you might already know, we have a very strong partnership with Intel, which enables us to build up on their innovation that they do on the chips themselves. So if you look at our instances from a couple of slides ago, for example, the M3s, CC2s, Sierra1s, and G2 instance types are built on Intel Xeon Sandy Bridge CPUs. And then we have a couple of later instances that are built on the Intel Xeon Ivy Bridge CPUs. And then obviously Intel with that introduced also the support for advanced vector extension instructions. And then the latest instances that we released, which are the C4 and just a week or 2 weeks ago, the D2, are built on Haswell chips. So one of the factors that goes into the fact that we have multiple generations is just the fact that we can build upon innovation that is happening on the Intel side. Another piece is networking. So we have introduced AWS proprietary 10 GB networking within our data centers. Almost all of the latest and later instances have this performance factor built in. So the highest performance you get the full 10 GB on the 8 extra large instance size. And then as you have smaller instances, you get a little bit less than that. There's something, this year would be something that not a lot of you might care about right away, but this is sort of one of the snippets that I built in here for the people that have already started working with us or have some very specific requirements around some more needy workloads that they have, which are placement groups. So actually, when you request EC2 instances from us or want to fire up a couple of instances, you can let us know if you need them to be in a placement group, which means the latency between them can have a much higher performance than if not so. Because when we look for a placement group for you, we basically look at how many of the, or can we fulfill the request for all the instances you need to live within a certain proximity. So we would look at all the open slots basically where we can place your instances and see if they can be in a certain proximity to where you can support some tightly coupled workloads that have a lot of chatter between them and are very latency sensitive. And this here is something for the sort of very advanced crowd. And again, even for the beginners that might have just very specific workloads, which is enhanced networking. So we introduced the proprietary network. That's pretty broadly available. We also introduced enhanced networking, which is currently only available on the D2, C3, C4, R3, and I2 instances, only if you run in VPC and only if you run with HVM virtualization. What enhanced networking allows you to do is to drive down the network and latency jitter that you might see without enhanced networking, and it also gives you a much higher packets per second performance. So if you have some kind of workload that sends a lot of packets between the instances, you would tap out without enhanced networking at around, on an 8 extra large, the largest size instance, at around maybe 80 to 100,000 packets per second. So we introduced enhanced networking. If you turn that on, now you get over 1 million. So if you have something that you might have benchmarked on EC2 a year ago or so, without enhanced networking turned on, that is very PPS hungry, I would encourage you again to come back, use some of those instances, and my slides just disappeared, but use some of those instances and see what kind of better performance you get. So regardless of what I push, it's not coming back, which might be a problem. Can we try to get it back on? No? Let me see. If I flip this up, will I see it on here on this screen? Oh, OK. We'll start over. So thank you for coming. Oh, this is just a pause screen. OK, I can't even. Man, you're really throwing a curveball at me here. I got to let you know this is. This makes it a bit tougher. Let's see. All right. You know what? I think I do remember the next slide. So performance factors, CPU, networking, and another one is storage. So I mentioned earlier that an instance is comprised of a couple of different resources that you get with that instance. And one of them was local instance storage. Oh, here we, no, OK. See, I would have missed one. So actually, I'll skip over this one for the sake of time and also because I really just put this in here. And by the way, all these sessions are being recorded and will be put online for your consumption later. So for people here that are really interested in enhanced networking, especially people that might have already something running on AWS, I wanted to make sure that you know that even if you have an older AMI or a custom AMI, you can make a few changes and checkmark a few boxes so that you can turn on enhanced networking and then take advantage of the networking performance increases that enhanced networking can provide. So the kernel version, VPC, appropriate function drivers, and so on. So I'll just jump over this one for the sake of time. And I was right, which is good. Next performance factor is storage. So we have local instance storage. So one of the benefits of EC2 is the fact that you can turn on instances as you please on demand. Now, when you have local instance storage, that also means that if you turn off an instance, that local storage will disappear along with the instance. The great news is that it comes with the instance and you can use it right away. But where the performance factor comes in is that, in addition to that, you can also have persistent storage, which we call EBS. And I'm assuming, I was going to go over this in a little bit more detail, but since we just wasted a couple of minutes with this slide mishap, I'm going to just skim over it. But one of the benefits of EBS is the fact that it's persistent. So you can attach an EBS volume to an instance, and you can actually detach it. You can shut down an instance, bring back another instance, or bring it back up later as you need those other resources again. And the storage persists on the EBS volume. And then you have different options for your EBS volumes. You have magnetic volumes that are very, very cost effective. You have general purpose SSD volumes that can support more needy or IOPS needy workloads, and then you have provisioned IOPS that just can get you consistent, large IOPS performance the entire time. So the great news about EBS is you can right-size it depending on how much storage you actually need. You can select the type of EBS volume you actually need to get the right performance you have, or the best cost, and you can decide between those two. And the other thing is or why it's a performance factor is also that with some of the latest instances, we realized, based again on the feedback we got from you, obviously not the dense storage or storage high instances, but some of the compute and memory instances, for example, we got a lot of feedback that said, hey, the instant storage is great, but it comes in certain sizes, and I can either I need a better performance, or I don't need all that storage, or I need more than that storage, and I need to additionally provision EBS. So we decided, for example, on the C4 and the T2s, to not provide any instant storage, so that it's just up to you for how much storage you want to pay for, or what kind of performance you want to have, and then you can also decide to have EBS volumes live longer than your instances, so that you have persistent storage. And the other great thing about EBS is, as you think about the generations and taking advantage of the latest hardware and the latest capabilities that come with the latest generations, EBS makes it a lot easier to make those transitions, right? If you have an EBS volume attached to an instance, you can sort of kind of freeze it in time, you can detach it, you can shut down a C3 instance, for example, bring back a C4 with the appropriate AMI, reattach the EBS volume, and just keep going, and all of a sudden you have a lot more power behind that. And then for the sake of completeness, I also listed S3 and Glacier here, our object store and our cold storage services. Obviously, those are their own services. There's a lot more to them than me mentioning it for 30 seconds. But it's an option for you to store data and then to pull data into your instance if you want to work with it. So one last thing I wanted to talk about with virtual machines is the T2, because it's an interesting concept that we just introduced last year, which basically, again, was born out of the feedback we got from our range of customers, which is that while these different instances and the different sizes and the power that comes with those instances is great, I actually have a lot of workloads that do require a lot of power that would fit very well on like a C3 large or whatever it might be, but they don't require that power all the time. So how about you guys doing what EBS was also introduced, which is burstability. So with the EBS SSD volumes, you saw that we could support a certain base level of IOPS, and then you can burst above that as your workload was growing, either every hour or certain times of the day or whatever it might be. And all that is managed by a credit system. So a credit system that allows for you to, or that makes sure that you know that you can burst for a certain amount of time, and that allows for your instance to scale up to that level so that you can support a workload. And then T2, as opposed to the T1, first of all, is built on much more capable hardware. It has the burstability built in. It has the credit system built in. And it comes in different sizes. So it's great, for example, also for benchmarking. If you have a workload that kind of goes up and down, let's say it's an internal database at a large enterprise that only has a couple of users. So it gets hit a couple of times a day, not that often. But if somebody hits that database, they want to see the results, right? That machine needs to start working, and it needs to start working well. So that's the sort of stuff that a T2 is great for, this kind of bursty performance. And then you can look at, you can start out with a micro, which is extremely cost effective. T2 is EBS only, so you have an EBS volume attached. And if you recognize your T2 micro running out of credits or not being able to support the type of workload that it's supposed to support, you can detach the EBS volume, you can shut down the T2 micro, you can bring up a small or a medium that provides more credits and more burstability. And in the case of the T2 medium, even then 2 vCPUs as opposed to 1, reattach the EBS volume and just keep going. I always have this sort of example of your cell phone plan. So if let's say you have a cell phone plan that is 400 minutes, and then you get a job promotion and you find yourself having a different workload, you find yourself on the phone a lot longer or a lot more, you can call your cell phone provider and say, hey, you know what, I actually need 900 minutes. And the goal is not for you to look at the credits you have still remaining in the system all the time. The goal is for you to kind of know, okay, I'm running out of minutes, I need to upgrade, and then to just leave it alone and be able to do whatever it is you need to do. And that's sort of how we think about the T2 instances. So there's a credit system built in that manages how much you can burst, but it's more meant for you to kind of level set on what type of T2 do I need, and then for the most part, it just works in the background. It just works. And when I say it's the lowest cost instance, so first of all, it's available in the free tier, which you can see here. But let's say you run out of the free tier, or you decide you love them as much as I do, and you fire up a bunch of them, then you can pay 1.3 cents an hour for a T2 micro. That's about $9.50 a month. It's extremely cost effective. So in short, I love this stuff, and I encourage you all to look at it. So why do customers use EC2? I already talked about why different workloads require different instances and how they were kind of built out of the feedback that we got from you and the needs that we saw in the industry. But overall, why do customers use EC2? If you were listening in on the keynote this morning, you might have already heard some of this, which is, well, I'm kind of disappointed. I built this slide deck about a week and a half ago, and now Andy stole all my thunder, not just because he's a better presenter, but because he had the guy that I'm just quoting actually up on stage and telling you how great this stuff is. So it's a little bit repetitive, but maybe still good for you to think about. So AdRoll is a super interesting startup. They're a marketing company that has an ad retargeting platform. It needs to be very performant. It is latency sensitive, especially the RTB stuff that they're doing. So they're using Dynamo, which is something that was mentioned in the last talk as well. But they also use EC2. And while I love this quote here that kind of shows how they were able to support, and this is just a fantastic number, a 15,000% growth in 1 year. Well, they were able to support that and do so cost effectively. And while I like this quote, I like the quote that Valentino gave today even more. He said, basically, in short, he didn't say this, I'll say it, his technology is fantastic, but without AWS, I wouldn't even be here up on stage talking to you. So just the fact that he could onboard additional customers, connect to different exchanges around the world, scale up instances, scale them back down, and do all that cost effectively and without any of the operational overhead that usually goes into a global reach and having his people think about capacity planning and supply chains and data transfer contracts with different entities around the world. Just taking all that workload off and enabling his team to just think about the stuff that really matters to the platform was part of what enabled this growth. And I'm just proud as AWS to be part of that. And then I selected a different second example as well. Obviously, we have a wide range of audience members here again today. If you care specifically about, healthcare, financial services, startups versus enterprise, we have a website that has a wide range of different case studies that you might be able to learn from and think about. Here I just selected two. I'm glad that Andy didn't choose this one as well, because else I wouldn't have anything new for you. But this one's interesting from a little bit different perspective. A lot of you will know Condé Nast. It's a publications company. A lot of the publications that are part of Condé Nast, you'll know something like Wired and The New Yorker and Vogue and things of that nature. And they managed all those publications out of their own data center. And they had, they didn't have the same challenge that AdRoll has, but they had the same idea that their internal resources were very busy managing data centers and reacting to demand for their different publications. And were not able to fully focus on those great brands that they had and serving the customers as well as they could. What's really great about Condé Nast is how fast they were able to do this. So they did a complete 4-month data center migration, so 500 plus servers, 1 petabyte of storage, mission critical apps, and that's really key, HR, legal, sales, database apps. And they have a pretty cool video as well. I think it was either reInvent last year or one of our summits where they showed just how excited they were not just to move over to AWS, but then to go into their data center, decommission all the racks, and then at the end of the video, they just turn off the light switch and the data center goes black, which was a great day for them because they were just finally out of having to manage that operational burden. So this would be my second example. And the result, again, is, in their case, 40% savings that they saw and 30 to 40% performance increase, which is just tremendous if you think of both of those ends sort of coming together and what that means to a company that can now work a lot more agile and take advantage of some of the things that we have built on the infrastructure side for them. So those were obviously, the results are sort of that are highlighted in these use cases are the ones that you hear often, but they're all, they're great overall results, but they're all built on all these different benefits that come along with EC2, which are elasticity, the fact that it's completely controlled, flexibility, breadth of functionality. And I just listed a couple here, and I want to dive into a few because, and the reason being is because during this talk, as I said, there are a lot of people that are really new to AWS and that have questions around, how can I control my environment? How reliable is it? How secure is it? And so I just wanted to dive into some of those again. So the first one is elasticity. So this is something that's just showing you an example. It's a fictional example, but it's born out of some of the things we see with our customers. And the fact is that a lot of server load is not evenly distributed for a lot of the workloads that you have. A lot of times, if it's something that's customer-facing, it will be something that maybe just starts scaling up in the morning. And in this case, this is obviously the random part. It peaks at noon. It might be something else, depending on what type of application you're running. And then it comes back down. So we have 24 hours within a day. And then we have a load that comes in, kind of peaks, and then comes back down. So if we just arbitrarily say, OK, these 2 units of server load can be managed by one capacity, or the capacity of one server, then what we would have to traditionally do is we have to provision for peak capacity, because we want to make sure that as we have all these customers coming in, they don't get a degraded performance. This is where we really show our value to our customer. This is where we really want to make them happy. Actually, and this is even conservative, because if you think about it, are you really provisioning right there? Do you actually know where your peak is? And what do you do if you have hardware failure? So then in reality, we would see things like people not having 2 servers in their data center or under their desk or whatever it might be, but 3 or 4. Well, what you can do with EC2 is that you can react to your demand or the demand you're seeing on the fly by provisioning additional servers in the cloud. So in EC2 land, it would basically look like this. You have a server running for the first 8 hours. Then you have 2 servers running as you provision for peak, and then you scale back down. And this is a pretty simple example, but it can show you sort of, this would be, and the peak to valley here, by the way, is really not extravagant or anything like that. It's actually pretty conservative. But it shows you that in a scenario like this, you can have 33% savings just for the fact that you're elastic now. And not only that, you can actually, if you have an unforeseen peak, you can react to that as well, and you can have a better customer experience. So elasticity kind of helps you, on the performance side as well as on the cost side. Now, again, like I said, this is in some ways a conservative estimate. Let's say these wouldn't be 1 and 2 servers. This would be 100 and 200. You can have incremental changes. As you see here, the orange area is actually covering some of the area above the server load. So if you can incrementally go from 100 to 200, you can squeeze out even more savings. That said, you probably want to stay somewhere within a safety range above your load, just to make sure that the last customer coming in has the same performance that you expect for everyone to have. This is another example, again, not extreme and pretty powerful in that it doesn't only show elasticity and cost savings, but also something else that people start thinking about as they wrap their mind around the fact that elastic capacity is just available to them on demand. So in this case, we have not the hours within a day, but we have the days within a month. So let's say 30, 31 days, whatever it might be. At the end of the month, we do some log analytics, or we do some payroll, or we do some sort of batch processing. What happens traditionally is, if you have a monthly predictable peak, again, you plan for peak. So you have this much capacity that lays around a lot of the month. And then within EC2 land, you can just stay right around that line and provision more instances as you need them towards the end of the month, creating something like 75% savings. So again, same story, right? Savings, elasticity, being able to go along. What's interesting here, though, is the thing about the fact, these 6 servers cost something. And there's a certain budget you have, and you need to make sure that you get your log analytics or whatever the batch process is done before the end of the month. So you said, you know what, the minimum I need is 6 servers because I get my data on the 25th and I need to be done on the 30th. So just an example. But now that you have elastic capacity available and you can save money, not only can you save money, but why 6 servers? Why not 12? Why not 18? Because, hey, when you're done, you just scale them back down. So all of a sudden, you don't only get cost savings and elasticity, and you don't have to worry so much about your peak capacity, but you can actually shorten the time to results. And that's what's really interesting. When people start thinking, how do I take advantage of this cloud thing? Not only showing savings and being elastic, but all of a sudden actually having people not have to wait on results, having results quicker, being able to iterate on them, and on and on and on and on. This is something that goes along the topic of scalability that I mentioned earlier. So first of all, scalability because of the capacity we add all the time, the global reach we have that you can take advantage of, but also then the fact that that scaling can be automatic. And again, this is something very much born out of the feedback we have been getting from our customers, which is, all this elasticity is great, and I love it, but can you help me make it easier for me to manage? And basically the answer is yes, we can, with two services that we introduced. One is auto-scaling and one is ELB. ELB is an elastic load balancer that can distribute the incoming load among the servers that you have provisioned in the EC2 cloud. But now the other side, or the second piece of the puzzle, is auto-scaling. And auto-scaling is a service that lets you determine what type of metrics you want to measure and act upon. So let's say you say, I have 5 servers running, and whenever the CPU utilization for a server goes above 75%, autoscaler, add another instance. And when I hit it again, add another instance. But you know what? When we go below a certain utilization, I also want you to subtract the instances and shut them down again. But just to be safe, as maybe a couple of customers might come in floods, we want to make sure they have a good experience. Let's have a minimum of X servers running all the time. So you define your autoscaler on one end, and you define your load balancer, and you can have a lot of operational burden around elasticity managed for you, as opposed to you having to react to that. So very powerful, and both things I would want you to look into. And again, both probably worth revisiting on your own and reading a little bit more about. Completely controlled. So this might be super straightforward to a lot of you, but the truth is I get questions about this all the time. We have, and this is something I'll mention again in a little bit, we have a shared responsibility model, which means we manage everything from the infrastructure up to the OS, and you take it at the OS level and go on up. And that means that you have full control of your instances in the cloud. You can log on as root. You can log on as an administrator. You can install the software you need. You can start and stop your instances. You can make configuration changes, and you can create AMIs. And I think I actually didn't define this yet, but AMI is short for Amazon Machine Image, which is basically the image that you can run on top of an instance that has maybe certain software or data, whatever it is that you want to run on it. And then we have AMIs available in the marketplace that you can just use and quickly deploy, or you can create your own. And so this comes back to the completely controlled, right? You can create sort of an instance image as you want to have it, and then you can redeploy it, and you can control who can do that and who cannot. This actually leads me to 2 items that are not on this list that are a little bit, again, on the advanced level, but very important when it comes to control and security, which is there are 2 services that are also not just EC2, but cross-service applicable, which are IAM, which is our Identity and Access Manager, where you can determine who can do what within my environment. You can select groups or individuals to be able to start instances, stop instances, make configuration changes, make software changes, or whatever it might be. And then the second service that also is not just EC2 specific, but cross-service is CloudTrail. And CloudTrail is a logging service that logs these different changes that are being made. Only the changes that you designate in IAM your team members are able to make can be made, but then you might still want to know who made what change at what point in time, so you have auditability. CloudTrail and IAM are 2 of those, maybe not advanced, it's probably relevant to everybody, but 2 of those things that I would also encourage you to read about. Flexibility, this is, more or less just a summary of what I mentioned before, but I do want to reiterate it because it's not just the fact that you can choose an instance type and you can choose how much storage you want to have and how high, or what the performance is for that storage that you want to have, and your operating system, and you can have your AMIs, but also the fact that you can make those changes on the fly much faster than in traditional models, right? All this stuff is readily available for you. You can shut down an instance, you can detach EBS, you can get a newer instance, you can just discontinue EBS volume, and then you can go to an SSD EBS volume. You can make those changes because those services are readily available. That flexibility is tremendous. There's actually something that I really liked for the people that have joined this morning, which is when the Nike presentation happened, what did he talk about? The indifferentiators or something like that. The fact that there's certain things that can happen on the back end that shouldn't have any different outcome for the customer on the other side. So things like disaster recovery, high availability, and the fact that you're flexible. You can make changes behind the scenes, below the hood, and you can make them very quickly and flexible, and your customers should not see any impact at all. Or whoever it is that is using your application. Reliability. So first of all, we have a very good track record. We have SLAs around EC2. But in addition to all that, we enable you to architect systems in a way that is highly available, as we call it. So a couple of tools here that help. First of all are the availability zones that I mentioned earlier. So availability zones are different zones within a region that are close enough in proximity to where we still call them, parts of the same region. But they have different blast radiuses, which means that, if one is affected, maybe the power or cooling or the fact that they're in different flood zones, the other one has a small likelihood of being affected at the same time. And you can take advantage of that. And you can take advantage of that by architecting on your own, but also by using ELB and autoscaling. And this would be such an example of how you can leverage that. So for example, let's say, again, we have a customer scenario. The customer's in the bottom left of the screen here. And then the first thing that happens is if you use our content delivery network, they get served a certain content, but then they can have requests that hit an ELB, which is that first little box you see here in the bottom left. And then you can have the ELB actually route traffic to your EC2 instances, but not just to your EC2 instances in one availability zone, but you can spread the load between 2 availability zones to your web servers. And then you can have 2 different autoscaling groups, right? Depending on how much load comes into each availability zone, those fleets of web servers can scale up or down. Behind that, you can have another ELB that then routes the traffic or the requests back to the application servers, again in 2 availability zones. And yet behind that, you can have database servers, your backup and your primary. So what happens now is that ELB and autoscaling can help you architect in this way, and they also have some automation built in, not just around the fact that you can trigger scaling up and down your fleet, but they also check for the health of your instances automatically. So if the load balancer realizes that one of the instances isn't performing the way we would expect it to, it stops sending traffic or content or requests that way. And at the same time, autoscaling has those checks built in as well. So your autoscaler can automatically say, something seems to be wrong with this instance. Maybe you have a hardware failure or whatever it might be. Let's shut down this instance, make the autoscaling group a little bit smaller, and then fire up another one right away. So think about it in the traditional sense where it talked about hardware failure and needing to provision not just for peak, but for these unexpected things that happen. You can build some of that automatically in your system. How do you deal with hardware failure? How do you deal with maybe even a catastrophic event that would take out a whole availability zone? However unlikely, you're ready for it. You use ELB, you use autoscaling, you architect in a highly available way that utilizes our availability zones, and you have very little impact to your end customer. And that's very, very powerful. Security, and this is something unequivocally stated, is our #1 priority. This is actually something else that came up in the Nike talk this morning, where the representative spoke specifically of AWS or of choosing AWS because of security being such a highly ranking item on his list, and that we have such great security. So coming back to something I mentioned, which is the shared responsibility model. We have, on our end, secured premises, secured access, built-in firewalls. We use best practices in the industry, and at our scale, we can look at the entire industry and all its facets and implement the best security that we can find, and that's out there, and it's for everybody to use. No matter what the scale of our customers is, you can have that network effect again, where we work with anything from a startup to an enterprise to government agencies that drive us to create the security and implement the security that we have. You can take advantage of it automatically. And then on your side, you can do things like have unique users with IAM, multi-factor authentication, create private subnets via VPC. We can encrypt data for you, or you can choose to do it yourself. You can have a dedicated connection set up, so you can have your on-premises data centers connect with a logically isolated group of instances in the cloud. And I'll explain a little bit more what that means. But that shared responsibility model and those best practices on our side and the tools we give you on your side in combination enable you to run with a lot of these certifications on the back end. So AWS is certified to run these types of applications, but obviously it takes 2. It takes us and you to work together. That said, again, we have a network effect here, right? People have asked us for HIPAA certification, FISMA, PCI. So when you start storing PCI information, we have that certification. It's readily available for you. We have people that have done it before you. We can show you how it's done, and we can help you with the architecture to be as safe as you can be and be fully aware of following all the best practices that go along with these certifications. VPC, so that's the virtual private cloud, provisions a logically isolated section within the cloud. So you can have private IP addressing between instances, and via subnets and route tables and security groups and network ACLs, you can determine which group of instances in the cloud are able to communicate with each other, with another VPC, with my on-premises data center, or if you choose to, with the internet. So you have full control around what type of communication can happen within your environment. So this is an example that kind of puts all these different topics together. So let's say, and we've seen this a lot, somebody either extends their data center because they still have a lease that runs for a couple of years and they want to start taking advantage of the cloud. They can have a VPN, or another option we have is direct connect. So they can have a direct gateway into the cloud, and then they can create subnets in the individual AZs, or you can have multiple subnets within an AZ, where you can restrict traffic, and then you can have, if you choose to, have some of those subnets be able to communicate out of the cloud. This is also something that's used a lot of times when people do data center migration. So when they want to move their data and want to move their workloads from their own premises into the cloud, they set up these VPNs and the subnets and so on and so forth, and then they kind of lock down what can happen within. Cost effectiveness, I think I kind of hammered this down, but there's one more thing, aside from the fact that it's elastic, is that we have different purchasing options for you. So again, the first thing, if you remember one of the first slides I had, on-demand was the only pricing option, and the only kind of, just showed that there's other ones now. But the truth is, it's still, one of the core pricing options we have, and it's super powerful. And it's what a lot of people take advantage of when it comes to elasticity. So pay for instances on-demand per the hour, as much as you need, and when you don't need it anymore, you stop paying and just shut it down. That said, we kind of reacted again to customer feedback. On-demand is great, but now that I deploy more and more in AWS, I have a couple of workloads that continuously run. For the fact that they continuously run, can we exchange some sort of advantages and commitment? So we basically say, if you commit to usage of a certain instance or instance type for 1 or 3 years, then you get a much better rate. And you know what? You also get a reservation, which means, and a reservation is not resold, is not oversubscribed. The reservation is just there for you, which means an instance of this type is reserved for you to fire up and shut down whenever you want. So capacity reservation is the secondary benefit as well. And then obviously the fact that you can lower costs quite a bit. And then there are spot instances. Again, goes back to something I showed you earlier, which is the fact that we add a lot of hardware every single day, keeping up with the demand that we see out there in our growing business. And obviously, we want to stay ahead of the curve, which means we have spare capacity. And that spare capacity is something that you can bid on for certain types of workloads that can handle either interruptibility or transient workloads. So if you have large batch processes, you can bid on a certain amount of capacity that allows you to take care of that batch process for a very, very cheap price. And actually, I have one of my colleagues here in the first row. This is, again, something that I can't dive deeply into, but it's very interesting to people that do something like maybe rendering or genomics and do like large batch processes and analysis, or some big data workloads, or people that have heard maybe of EMR, which is our managed Hadoop service. EMR plugs directly into Spot, so you can use Spot instances behind EMR to do some of that work. So anybody that's in those areas and is planning on doing a lot of work in EC2, I would encourage you to talk to me. I'll be available in the hall, but also talk to my colleague who is specifically in business development for Spot instances and can kind of share best practices of what different rendering farms have done, or healthcare organizations or whatever it might be. So reserved instances, we simplified this offering quite a bit. So for the people that have been around a while, this is now a lot simpler. The sort of rule of thumb is, and I don't want this engraved in your brain quite yet because we evolve and innovate all the time, but the rule of thumb is if something is running more than 60% of the time for a year, it makes sense to buy a reserved instance, because in a lot of cases, a reserved instance for the whole year costs as much as running on demand for 60% of that time. Which means after that, that's where you realize savings. And then, so that choice or that decision has been made quite a bit simpler. And then you still have different options of how do you reserve, or how do you reserve that capacity and commit to that usage, which is you can either pay no upfront, which gives you quite a tremendous savings. But for the fact that you don't pay upfront, it's a little bit less than for the partial upfront or all upfront options. And those are basically meant for the different customers we see out there, which are either maybe startups that are either cash flow constrained or have a certain cost of capital that doesn't make it really feasible or important for them to pay for a reserved instance up front, but rather have that money to put it back in the business. Or we have large enterprises that deal with budgets that say, I would very, very much like take advantage of the fact that my cost of capital is a lot lower and I get a lot more savings in EC2 if I just pay partially upfront or all upfront for my reserved instance. That said, we have 1- and 3-year options for reserved instances, but something else that might be important to you is the fact that we have our RA marketplace. So you as a customer can actually sell or buy or resell or buy reserved instances from the marketplace. So for example, if somebody says, I have a workload that I know will be running 70%, or the next, 9 months, let's say. So it makes sense, 100% of the time, so it makes sense to buy a reserved instance because I save over on demand. But at the end of the 9 months, I still have 3 months remaining. So you know what, I already saved over on demand, but I can still resell that reserved instance on the marketplace. And somebody else might benefit because somebody else might have a workload that's coming in that will be running nonstop for 3 months and then it'll be gone. So I encourage anybody here that has that kind of workload to look on the RI marketplace because there's really, really cheap options and sometimes even higher savings than when you buy the RIs from us. So very powerful for sort of different customers to pool their resources together and take advantage of reserved instances. And here back to Spot. So again, Spot is a really interesting opportunity for different workloads that can take advantage of it. The one thing I want to mention here, and then again, you can talk to my colleague in a little bit more detail, is the fact that these different instances in the different availability zones, in the different regions, all have their own markets. So as I mentioned earlier, Spot capacity is something that you can bid on and then acquire for your workloads by the hour. And then, as you're outbid, you will actually lose those instances. The fact is, though, that we have a ton of different pools. I mean, you saw all the different instance types and instance sizes that we have, all the different availability zones and all the different regions. If you can take advantage of the fact that you can move maybe from one availability zone to the next, or you have check marks in your workload for a batch process, where if an instance is taken away, you have the last saved point, and you can just continue somewhere else. Spot is something that can be tremendously valuable. You can get up to 90% savings over on-demand with Spot. So anybody that has large rendering jobs, batch processes, uses EMR, maybe uses other tools that have Spot plugins, and there are plenty out there. I think Jenkins is one of them, for example. All those people, I would encourage you to look at Spot and then also talk to my colleague. It's easy to get started. So this is something that I know my friend last year actually did a little demo on, but it's so easy, and we're already running out of time, that I wanted to skip this one because we have 4-minute videos, one 4-minute video for how to sign up for an account. And to be honest with you, I think it's very self-explanatory and it's super easy. But we have 4-minute videos on the Getting Started webpage that show you how to sign up for an account and then also how to launch your first instance. And I'd rather have you do that with your favorite sandwich in hand at home as opposed to me taking some of the minutes that I can share some of the more important information with you. But it's super easy to get started, and there's a free tier. So I would encourage you to just play around with it and learn about AWS and EC2. And the other part of that is the marketplace, which, like I said, there's AMIs on there, and there are different ISVs that provide AMIs for software that's packaged in a cloud-friendly way. So again, the same idea as with infrastructure. Instead of buying server capacity and being locked in and having maybe bought too much and then sitting on capital expenditures, you can have a similar scenario with some of the software packages that are out there. In this case, on the marketplace, we have 1,900 plus products, and I think this is one of the numbers that's out of date that was already higher in Andy's slides, in 23 categories that allows for you to one-click just deploy software packages that you can use on demand, and you see them as a separate item in your bill. So you can see this is how much I paid for EC2 instances, this is how much I paid for the software that I deployed. And once you shut down the instance, that cost goes away. So an on-demand model for a lot of the software packages that you're used to. So next steps, this is all that's remaining. Sign up for an AWS account, take advantage of the free tier, learn more on the website. So I hope I gave you some ideas of what other topics you might want to investigate. Join us at the booth and join us outside for any questions that you might have, especially people that maybe look for specific scenarios that they're working on. The two things I want you to take away from today, in addition to just taking away everything, is security is our #1 priority, and we love getting feedback. So once you started kicking the tires, please come back to us, let us know what works, what doesn't work, what you would like to see improve, and we'll take that back. And I can't make promises, but there's a high likelihood we'll act upon that very quickly. Thank you.